VPNs protect the connection, but they also protect anything that sneaks inside it. In IoT, that's not good enough. Today, we're unpacking zero trust at the network layer, what it actually means when it is enforced before traffic ever reaches your backend, how it shrinks the attack surface to near zero, and why outbound-only policy-driven access changes the game for scaling secure IoT.
Establishing these tunnels in all directions is also a security concern, because once the tunnel is up, anything can basically go through that tunnel.
That was Henning Solberg, IXT CEO and CTO, from our webinar on Zero Trust that we are building on in this episode. I'm Conor from IXT, and this is Beyond the IoT SIM podcast. Let's set a clean baseline for what Zero Trust for IoT actually means. Zero Trust isn't a product, it's a design rule. Never trust by default. Every flow is verified against policy, every time. In IoT, that policy lives in the network. The SIM anchors identity, the Zero Trust exchange becomes the traffic bouncer, and the default stance is deny. Your devices don't sit exposed on the public internet. They originate outbound-only connections via the exchange to your allowed services. Think telemetry headend, OTA update server, DNS, timesync. Nothing else. So instead of a big encrypted tunnel that anything can ride inside, you get per-device allow lists enforced before traffic ever touches your backend. And maintenance doesn't mean opening the barn door. With privileged remote access, you can grant a vendor access to one device for one protocol for a defined time window and watch the session, as opposed to handing out a VPN that can laterally roam. That's the shift, from encrypt everything to only allow what's explicitly known and prove it.
We are adding the Zero Trust capability to the network, which basically means that we are putting some, let's say, call it magic, in between the IoT device and the central headend. It's something we call the cell edge and the Zero Trust exchange. What it essentially does is to make sure that the traffic that goes between the IoT device and the central sites is actually being inspected and is being secured, and the actual connection is going outwards from the Zero Trust exchange towards the headend and towards the IoT device. So that means that there is no way for a third party to go in and connect directly to the end device. That has to go through the Zero Trust exchange, and that can potentially inspect all the traffic, and you can set rules based on whatever you are allowing to pass through the exchange.
That outbound-only model is key. Traditional VPNs create a bidirectional highway. Once you're in, you're in. With Zero Trust at the network edge, devices initiate connections outward through the exchange. Nothing from the outside can probe, scan, or knock on the door because there's no door to knock on. Now let's talk about real-world scenarios. Imagine you've got thousands of sensors in the field. EV chargers, smart meters, logistics trackers. Each one should only talk to its designated platform. Nothing more. With baseline policies at the exchange, you define exactly what normal looks like for each device type. MQTT to your cloud endpoint? Allowed. Firmware updates from your OTA server? Allowed. Random outbound traffic to an unknown IP at 3 a.m.? Blocked and flagged. It's not about locking everything down so tight you can't operate. It's about precision, granting access where it's needed, denying it everywhere else, and having visibility into what's actually happening.
So for a typical scenario where you have, let's say, a number of EV chargers, or it could be sensors that's out there with a SIM, they are typically connecting to the mobile network, and they are then submitting some data to a central server. This is the baseline for the communication. This is what we expect for this device. We are expecting, for instance, an MQTT session or an OCPP session, for that matter, to a certain headend system, to a certain IP. That's what we expect. As soon as we see something that goes beyond that or outside whatever we have baseline as being allowed for this device, we could potentially block that traffic, or we could inform about this traffic. It's multiple ways to do it, but the key idea here is to allow only the traffic that's supposed to be allowed for the device, and everything else is handled and blocked by the Zero Trust Exchange.
And that's the fundamental difference. You're not reacting after a breach, you're preventing the breach by design. The attack surface shrinks to near zero because there's nothing exposed to attack in the first place. So if you're deploying IoT at scale, especially in critical infrastructure, utilities, transport, or anywhere NIS2 applies, ask yourself, are your devices sitting on the public internet with a VPN username and password between them and disaster? Or are they anchored in a zero-trust architecture that validates every session, inspects every flow, and denies everything by default? That's the conversation we're having with customers today. If you'd like to explore how Zero Trust applies to your deployment, reach out to us at IXT.io. Thanks for listening to Beyond the IoT SIM. I'm Conor, and we'll catch you on the next one.